seconds. Yeah.
Oh, actually, wait, hold on. Let me turn on my. Okay.
Great. Welcome everyone to the zkSWap and a quick introduction to zkSWap. Taking the session today is Howard. Yeah, and with that, I will pass it over to Howard to give a quick introduction to himself and share his screen to kick the workshop off.
All right. Nice. Hello, everyone. Thanks for joining the workshop. I hope you're having fun so far at the ETH Global Hackathon. Wait, can you see my screen? What's going on?
Yes.
Okay.
Right. Yeah,
So
you might want to just put it into full screen.
Full screen. New share. What do you see over there? I should be sharing the whole screen.
Yeah, you're not sharing like the whole screen. I can still see your desktop background and then a window open with zkSWap wiki.
Yeah, that's it. But
okay,
okay, I think that's it. Yeah. So I can share and I'm not showing the slide. So can you see the slide now?
No, I'm still seeing zkSWap wiki.
It's bizarre. I'm choosing the whole desktop. Sure.
Oh, we can see the slide. Just maximize your browser window.
Do you see the slide now?
Mm-hmm.
Yeah.
Yes.
Yeah, there we go.
That work. Okay. Now I'm the wiki. Is this okay?
Yeah, that's perfect.
And slide. Okay. So sorry about
No.
that. Thanks for everyone for coming. Yeah, I think like the whole rollup system is moving really fast, and the whole layer 2 ecosystem is evolving very quickly as well. So I really have to apologize for the lack of documentation and probably inaccuracy in the documentation as well. So some of this may be a little bit confusing because it is confusing and because the parts are changing. So if you guys have any question, you can just interrupt me in the middle, and I'll try to answer it the best as I can. And so I'm the smart contract engineer at zkSWap. So I mostly handle the smart contract component of zkSWap. So there's really quite a bit of stuff I don't really understand myself. So I'm not super familiar with how the zero knowledge proof system works. So I just know some basics. So I'll try to answer and probably relay some of the questions to the technical team. But I'll just try to do my best. Okay, so maybe a little bit of an overview of our project. So it's one of those layer 2 token swap protocols. It's an AMM on layer 2. And we launched in February this year, and we have about 20 people on our team. And so far, we have 1.5 billion in TVL and about $1 billion in liquidity. But we do about 150 million in trading value in a day. So it's doing pretty okay. And we have a payment, and we can do liquidity mining on layer 2, and we also have swap on layer 2. And it's based on zk rollup, so it's validity. It's using validity proof instead of proof, and all the data necessary is on chain, and there's no exit period. So pretty much the property of zk rollup. And we've done a lot of optimization on the proofing speed and the data storage requirements. So so far we've managed to get it to about 100 times the capacity and throughput of layer 1 Ethereum, and the gas cost per transaction is about 1/50th of what it costs on layer 1. And for users, the interaction is pretty much instantaneous. As if you have played around with the layer 2 applications before, it's really quite a game changer. In terms of the technical challenges we faced, it's really having to do with the zk knowledge system. The complexity of the zk knowledge proving system is directly proportional to the complexity of the application logic. And in our system, we implemented the ANN at the circuit level. So we had to do a lot of compression, data compression, and try to make the data as small as possible, so the circuits just directly proportional to the size of the input as well. So a lot of complexity in the input would also sort of recursively precollate down to the circuit level as well. So there's a lot of optimization opportunities in terms of the design of the data structures. And we've done quite a bit of work on the proof generation itself as well. So we had a implementation of a GPU implementation of the Planck algorithm, and the TPS reaches above 100, and we improved the implementation by 3 times. And there's still quite a bit of room for improvement as well. So we started working on this since last August. So we haven't finished all of our optimization ideas yet. So I think the proof team is saying they probably have another 5-time improvement that's possible. Yeah, so we'll see if that happens. And in terms of optimization technique, another big area is the aggregation proof, where we take instead of generating 1 proof per block, we combine multiple blocks into the same proof. And on chain, we could just do 1 verification for multiple blocks. So that saves quite a bit of gas as well. And with this improvement, we are looking at about 1,400 gas per transaction. So most of the gas cost is really on-chain data and just verifying the zk proof. And so as I said a little bit earlier, the aggregation proof helps quite a bit. And in terms of our roadmap for 2021, we're looking to support user listing of tokens, just probably later this month or next month. So there's one thing about token listing as well. There are hard limit in the circuit as well. So I said earlier that data structure complexity is a big issue. So one optimization technique in the zk rollup system is using token ID instead of token addresses. So on Ethereum, you can essentially launch infinitely many ERC20 tokens, and each of these tokens will have their own address, and that's fine. But in the zk rollup system, because the token IDs, we can only support 16-bit of token IDs. So that's a much lower limit for the number of tokens that's possible on the system. And this is really because of the circuit complexity, as we mentioned earlier. And so this quarter we're still working on optimization for the proving system. So there's still quite a bit of improvement there. And we're seeing some bottleneck in the proving system. So when we were doing our liquidity mining program, our system was congested just because the proving system couldn't catch up with all the demand. And we'll also probably do governance token this quarter as well. And coming up, we'll be doing a stablecoin swap on layer 2, something like Curve on layer 2 as well. We'll be working with exchanges and businesses in Asia and internationally to integrate our payment system into their wallets. So also providing on-ramp services for exchanges. And then going even a little bit further, well, we'll be working on general EVM on layer 2. We can have DeFi composability on our system as well. Yeah, and for the hackathon, so we'll be looking at probably for the community to try their hands on building arbitrage tools. So just maybe looking at prices on zkSWap and compare the prices on, say, a centralized exchange and try to do arbitrage there. I think there's quite a bit of arbitrage opportunities. And one interesting property of our system is the LP tokens. Even though the liquidity exists on layer 2, we also issue corresponding LP tokens on layer 1. So there's probably some interesting like things you can do with these LP tokens. So maybe you could use them as collaterals for different lending products, or you can build derivatives on top of the LP tokens. So we'll see what sort of ideas the community would have. Yeah, and then this is sort of our social media, as you would expect. There's like the Twitter zkSWap official, and also like the Telegram group, the official Telegram group. So you have questions and ideas, you could probably DM these groups. Yeah, so this is a quick overview of our project. So if there's any question, could probably take some questions before we move on. Yeah.
Thanks, Howard. Yeah, there was a question from YouTube, but I do see that a representative from zkSWap is answering that in the YouTube chat as well. I did paste it in the chat channel here.
Okay. Let's see. Where's the chat? Can you maybe read the question?
So is it not 100% zk rollups and it is validity? It was announced that a separate 100% zk rollups would be released mid-March, but there is no separate product. What implement is zkSWap currently?
I think there are like different security properties. So there's the data availability problem, and there's also the transition. Let's say the transition security. So transition is about following the rule of the system, and there's no way to cheat. So as far as that part is concerned, we are fully secure. And about data availability is more about whether you could sort of recover the system if we go down. So if we just like sort of nuke our servers, then there needs to be a way to use on-chain data to recover it. So right now there are some data we couldn't recover because this data is not on-chain. But theoretically, like these data could be backed up somewhere else, and you could use that data to recover. So you could put like a backup on Filecoin, then you can recover from Filecoin, something like that. But in terms of like security and safety of the fund, there's nothing to worry about. It's more about recovery. But coming up, the plan is to launch like to provide full recovery as well. So that's probably not going to be an issue going forward. But we're also considering like different ways to provide the same, like cheaper ways to provide the same data availability properties. So that's something that's still sort of floating around, like even in the ecosystem at large. So that's one area that's still being explored.
Okay, cool. Thank you. Another question is, where are zkSWap servers for L2 computation?
I'm sorry, where
are zkSWap servers for L2 computation?
Who's providing the services? Is that the question? Like who's providing the proofs, like the proving computation?
Yes.
Okay. Yeah. So right now, the proving system is just we are providing the proving computation. So it's quite hardware intensive. So the zkSWap protocol is just we have like lots of machines doing the proving. Yeah, I mean, that's pretty much the answer. And there's really no way to decentralize this either because the proving needs to be serialized. So you can't, it like doesn't really make sense to have a cluster where you distribute the zero proving process. Otherwise, you're really just redoing the proofs across the cluster. So yeah, so I'm not really sure like if there's a good way to decentralize this this mechanism. But then again, I mean, like the security of the system doesn't depend on like whether the proving infrastructure itself being centralized or not. So it's really more an availability issue than anything else.
So I'm Natalie from zkSWap. I would like to jump in for the previous question about the 100% zk rollups. We have actually updated to the full zk rollup version on March 22nd, and you can check it on our Explorer, zkSWap.info, and all data availability is on chain right now.
Okay. Okay. Cool. Yeah.
Great. Maybe we just do one more question before you continue, and that question is, do you plan to support zkSWap with tokens from multiple EVM compatible chains?
EVM. Yeah, I mean, like, so like, I think like cross-chain bridging is a whole kind of worm in itself. So like, as long as there's ERC20 on their one Ethereum, like however it's created, like either through a bridge or through some sort of some sort of say cross-chain issuance. So there's a lot of DeFi protocols going on where they launch like different versions of their own protocol on different EVM chains, and on each chain effectively there are siloed tokens of the same protocol. So as long as there are tokens on Ethereum, then like we're happy to work with like different chains. As far as like crossing different layer twos, I think that's still like sort of in the air, and nobody really knows how it could work. There could probably be bridges between like different layer twos in the future. I think there are like projects working on that. So I think it will happen in the future for sure. And like we also have like EVM compatibility planned on our roadmap. So once that happens, then I think it will be easier to build bridges between different layer twos. But so far, you really have to go through like layer one. Yeah.
Thanks. Yeah, I think you can maybe continue with the rest of the session.
Yeah. So as I said in the beginning, like a lot of the documentation is like really quite rough right now because we're just working really hard on the features. So there's like some basic like APIs where you can get like a list of the supported tokens and like account infos and account balance. These are all there too. So like all the data queries are pretty straightforward. So I'm probably not gonna get into too much details about all these like list of transactions. So this is pretty much like the API that zkSWap Explorer uses. I think these are pretty straightforward. So I'm gonna spend more, maybe a little bit more time like at dissecting the structure of a layer 2 transaction. And the process of creating a layer 2 transaction. So there's like one API, one post API for creating and submitting layer 2 transactions, and it's the same API for like different operations. I think that the main operations are like swapping tokens, adding liquidity, removing liquidity, and sending, transferring to like recipients. And these are all using the same RESTful API. But the transaction structure will be different for like all of these different operations. So so this is like the documentation for the RESTful API. And for making transaction, so here's a document that sort of walks you through how layer 2 transactions could be constructed. So first we start with like crossing from layer 1 to layer 2, and this is just a matter of depositing some money and calling like the API contract, the contract API methods, and depositing some fund into the zkSWap contract. Then it will be picked up by the system, and a corresponding balance will be created on layer 2. So this is pretty straightforward layer 1 operation. Yeah, so we'll just move on to the interesting part. So this is just like typical like Ether.js thing. You load the zkS contract, then you load your wallet, and then you just call the method, like the deposit ERC20 method, to deposit the money onto layer 2. So that's pretty straightforward. It takes about 20 minutes, I think like 15-20 minutes for this to complete. And on layer 2, the way layer 2 works, the layer 2 system uses a different set of key pair and uses a different cryptographic primitives than from layer 1. So we have to generate a private key on the front end, and the private key for layer 2 is generated from a signature. So you actually use the MetaMask wallet to create a signature, and using the signature as the seed for the layer 2 private key. So the layer 2 private key is deterministically generated from a layer 1 wallet. So this is like the process of how you generate that. Yeah, and this is you have to register the generated private key with the layer 2 system, because for every account on layer 2, you are assigned an account ID, and the account ID is actually limited. I think that to about 40 billion accounts. So it's not there's like an upper ceiling to how many accounts there could be. Just, again, for like data compression reasons, for efficiency, data efficiency and circuit efficiency. Yeah, so once you generate a key, you have to register with the layer 2 system, and then for every operation you make, you use the generated layer 2 private key to sign the transaction. So here's the code that signs a layer 2 transaction. So so you use the private key generated above, and then all the transactions are actually just concatenated bytes. So for example, the first byte will determine the operation. So the operation will be like either like transfer, swap, adding liquidity, removing liquidity. So the first byte is the operation, and then for each operation, it's just a series of bytes of the data that operation needs. And we have some missing documentation here because we are still working on like some parts of it, but we have an example of a swap transaction on layer 2. And so as we said, the transaction is really a sequence of bytes. And for the swap transaction, the very first byte is the swap operator. So it's like the 0B type stands for swap. and then just a sequence of like different a sequence of the necessary parameters, like from which layer 1 account to which one layer 2 account, and then like the token amount in, token amount out, etc., etc. The chain ID, this is for security reasons to prevent replay attack on different on possibly different layer 2 chains, possibly different layer 2 systems on different chains. So you could theoretically have a layer 2 system on, say, Binance chain, but if the layer 2 system doesn't have a chain ID, then you could possibly replay a Binance chain layer 2 on the Ethereum chain layer 2. So the chain ID is there to prevent that happening. Yeah. So this is like a sequence of the transaction data necessary, and then you concatenate everything into one byte that you create. You create a signature of this bytes. Then you just pass in the whole thing as a JSON structure to the API, to the RESTful API in the previous page. Yeah, and so this is really the data that goes on layer 2, then be packaged into a layer 2 block. Then that will be a proof will be generated and submitted on layer 1 and verified. And there's one extra thing is really for sort of like usability and security, but it's not really relevant to layer 1. So so we actually generate the layer 2 private key in the web application. So theoretically, user could just click a button and then just send the transaction immediately without having to go through MetaMask. So this thing here, so we actually still sign a message with MetaMask wallet. So this is really just to give a feedback to a user. So when the user clicks a button, then a MetaMask request, which is sort of the MetaMask wallet will pop up a request prompting the user whether a signature should be provided. But this signature is really not necessary for the security of the system. It's really to provide that experience of user confirming something. And the other possible security issue is, suppose there is an injection into the website, then it's possible that the injection just creates like malicious transactions onto layer 2, and the layer 2 system don't know any better. So this message is also a way to double verify that a transaction is both verified by a layer 2 key and by a layer 1 wallet. So this way we can sort of mitigate the possible risk of an injection attack. But this is really not strictly necessary for the layer 2 smart contract. And if you go into the smart contract, you wouldn't see anything related to this signature. Yeah, that's pretty much all I have to share.
Just jump in, sorry. If you go a bit up to the JSON file that you showed, how would you go about generating this whole JSON file using this, like the simplest way possible? Like what extension would you use? Would you use web3.js, and how would you get that?
Yeah, we are preparing an SDK. So before that's ready, you just really just kind of like cobble together something by yourself. So, but I think we'll have an SDK like quite soon, I don't know, in a week or two. So when that's ready, you just like import the npm package. Then you can just like use the API that way. Yeah. Does that answer the question?
Yeah, thanks. Just like how would you generate the signature then without the SDK? you would just sign it?
Using the covered bluff. It's really quite primitive. You just use there's the zkSync crypto, so we use the same cryptography as zkSync, right? Then, as I said, you concatenate the transaction data into one message, one buffer, then you assign it with the zkSync cryptography. So you could do it just by hand in your script.
Oh, okay, thanks.
Yeah. So if you're doing some sort of arbitrage, then this is actually pretty straightforward. You don't need to wait for the SDK. You just do it. It's probably, I don't know, like dozens of lines of code. So it's not that bad. Still kind of ugly, but it's not bad. It's not too bad. Yeah.
Great. Thanks so much, Howard. I really appreciate you taking everyone through that session. If any of your questions weren't answered in the chat, I will be posting them in the zkSWap sponsor channel, and the zkSWap team will reply there. But thank you so much. And Howard, if there's anything you'd like to close off with, otherwise,
Good luck, have fun.
Great. Thanks, Howard. And thanks everybody for joining.
Okay, thanks.